How you guys doing? Welcome to day 4 Precalculus. So today we're going to find the domain, and most students have a hard time in finding the domain because they don't know what domain means. And let's get the definition down. So domain is the set of all possible values of the independent variable. So basically what it means is if I plug in x values, you're going to get a real y value. A real y value. Okay. Alright. So that's the meaning of it. So I'm plugging x value, a real number, I'm going to get a y value out of it. That's what it's trying to say. So let's do some examples. So copy this down, pause the video, because this is really the basic of understanding what domain is. It can get more complicated, but I just want you to know the basics. So really, this is the basic what domain means. So okay. So I'm going to erase it. So let's do some examples. So the first one, A, domain of polynomials. So I'm just gonna write polynomials, okay? Let's not write. So we're all finding the domain. So let's look at polynomials. What's the domain of polynomials? An example, what a polynomial is, we have x and x squared plus 3, doesn't matter. So why is that? Why is the domain of this? What's the domain of this? The domain of this is all real numbers. Why is that? Because I can plug in any value for x, I'm going to get a y value. That's why the domain is all real numbers. So there you go. B. This is polynomials. Domain of even roots. So domain of even roots, okay? Example, square root of x, for the fourth root of x, sixth root of x, these are all even. So the domain of this, let's just go to the most common one, square root of x. What's the domain of that? That this has to be greater than or equal to 0. Why is that? Right? Let's say I don't know this, or nobody had told me this. Why is this the case? Let's do some example. Let's do x equals, let's plug in x equals 1 for this problem, square root of x. So we have a function, f of x equals square root of x, right? And f of x, and then let's plug in 1. What do you get? 1. What if I plug in 0? I get 0. What if I plug in negative 1? I'm going to have I, right? But if you look at your calculator, I'll tell you there's no, if you just have a scientific calculator, it'll probably tell you there's no solution or error. Okay, so it's I. Or in this case, no real solution. So what do you think the domain is from based on this? If nobody told me, this would be it, right? Because I could basically saying that I could have any number except negative numbers. Plugging negative 1, I get I or no real solution. I can just say no real solution. Okay, that's why. Domain of all roots is x is greater than or equal to 0. Or you can, this is called set notation. So I'm going to write in set notation. All I got to do is this. And the interval notation would be something like this. That means it's included 0 and it's going to infinity. Set notation, interval notation. So let's do C. Domain of odd roots. Example, cube x 5 8x, 7x. Okay. So the domain of this, what do you guys think? If I didn't tell you what the domain is, can I plug in any number? F of x is equal to cube root of x. So can I plug in 1? How about 0, -1? Okay. So if I plug in 1, I get 1. I plug in 0, I get 0. Plug in -1, I get -1. So in this case, I tried negative numbers, and I tried 0, I tried 1. I still get any number. So the domain of this is all real numbers. Okay, so domain of odd roots is all real numbers. Domain of even roots, it's got to be 0 to positive. Inside, it has to be positive or 0. Here, it's all real numbers because I plug in any number, I'm going to get a number. So if I plug in 1 for x, I'm going to get 1, 0, I get 0, -1, -1. Here, I plug in -1, I get 1, all those things. So that's why that's all real numbers. Okay, so that's for that one. I'm going to erase it. So if you didn't get that, go back to the video and rewind it. Rewind, they have a rewind button nowadays. Okay, you do. So let's go with the domain of rational function. So example 1/x. So what's the domain of this? If you don't know what the domain is, just think about it. What numbers can I plug in? So I'm just thinking about, okay, let's plug in 1. I'm gonna get 1, right? So this is the function. So let me just erase it. So example, f of x is equal to x, 1/x, right? So if I plug in f of 1, I'm gonna get 1, f of 0. What do I get? How about -1? I get -1. If I plug in 0, I'm going to get 1/0. That's undefined. So the definition of this, not that x cannot equal 0, but the bottom cannot equal 0. So common mistake students make. So you got to make sure you understand that. So there you go. So the domain of this one is going to be, this is going to be in set notation. And this is called interval notation. So let me just write that here. So you guys are like, what is that? So there. This is called set notation. Set notation. And then here, we write interval notation. -infinity to 0, union 0 to infinity. Okay? So let's do some examples. All right. So let's do some examples. So let's do a 2x squared. All right, so find the domain of these functions. Well, it doesn't have to be a function, so we just want to know the domain of this. So you want to be more precise, why not? Let's just put an f of x, right? So what's the domain of that? Domain of this is what? We got to identify, first of all, this is what? The polynomial, so the domain is all real numbers. Why? Because I can plug in any number, right? B. Yeah, 1/x plus 3. Find the domain of that. Okay. So what's the domain of this? If you said x cannot equal 0, that's wrong. Remember that I mentioned that this bottom cannot equal 0. Okay? So you're gonna set the bottom equals 0, so x plus 3 cannot equal 0, so x cannot equal -3. So you want to write instead notation, it's gonna be this. And involve notation, it's gonna be -3. Union -3. 2, 3. There you go. That's supposed to be a 3. Okay, there you go. All right, so moving on. So I'm gonna erase this. So I'm gonna erase this entire thing now. Okay. All right, so let's see some more examples. So it doesn't have to be f of x, but just why not put f of x? Okay. Let's just make it a function. So what's the meaning of this? So remember that the inside, if you set x is greater than or equal to 0, that's wrong. Wrong, right? Because it could be 0, it's just the bottom, the inside cannot be negative. Or it could be 0, it just can't be negative. So x plus 3 has to be greater than or equal to 0. X is greater than -3. So basically you want to write that notation. And an interval notation will look something like this. There you go. Just depends on your teacher. I personally sometimes I kind of whatever to me is less writing, and I'll write it that way. So this is less writing, so I'll write it that way. But depends if you're asking for some notation. There you go. Interval notation. This is how you do it if you're depending on the question. Okay. If I was your teacher, this is class for you. You're taking this online class. I would say whatever you want. I don't really mind. If I said interval notation, write it this way. Said that they should write it this way. Okay. All right. Let's do more examples. So we have this cube root. Okay, what's the domain of this? Cube roots, I can plug in any number inside, right? So this is all real numbers. That's it. So that's that. Now let's do some more. I think that should be good, right? Okay, let's do one more problem. It's dealing with this. E. Let's just find something. No, that's fine. So make sure you understand this really well. And if you need to go back to the video, pause the video, then feel free to do so. So, all right, ready for the practice problem? So practice problem is like a pre-quiz. If you get one question wrong, go back to the question, understand why. I might throw in some tricky questions. So it's okay if you don't get all of them correct, but just think about it. So pause the video if you have to. So let's do some problems. So domain, no, done with domains. So that's number 1, f of x. Find the domain. So number 2. Number 3. Oh, that should be fine. Okay. Let's stop. So pause the video if you have to. It's supposed to be a 1. Class is really fast today, guys. So Sorry about that, but it's the way it is sometimes. So you get out of class early today. We are less than 15 minutes in the video. A lot faster than I was expecting. And we're doing practice problems already. Okay, let's do this. So the domain of this is a what? Polynomial, so this is all real numbers. That's the domain, right? So in your test, if you have different question, you would write domain is that. I'm just gonna write here just to emphasize that that's what you're doing. Here, what is the domain of this one? So x minus 5 has to be greater than or equal to 0. Oops, I'm thinking of something different. X is greater than or equal to 5. So that's a 5. And then you have what? I'm going to write it in set notation because it's easier for me. 5 to infinity. I mean in rotation, so if you write it in set notation, basically it's the same thing as that. It's going to be this. Okay? So set notation, in rotation. Okay, number 3. So number 3. F of x, f of x, x plus 7. So what's the domain on the top? This is a cube root, so I can plug in any numbers. It doesn't matter if this is x squared or x cubed, x to the 4. I can plug in any numbers because the cube root, this is a polynomial, so as long as it's polynomial inside this cube root, that's a better way to explain it. It's all real numbers. So as long as the question is a polynomial, and that's a really good way to explain it. Inside the cube root, the domain is all real numbers. How about this one? This one is going to be x, that x cannot equal -7, right? Instead in rotation, I gotta write it this way. Okay, that's one way to do it. In rotation, set notation. If you got all of them right, that's good. That means you really understand the domain so far, or at least the basics of it. So let's do some slightly different questions. So let's do it. What was that? 3, 4? Right? 3, 4? Okay. This is supposed to be 5 now. Polynomials. That was 5. Right? Oh shoot, I forgot. Okay, I'm not sure what that was. 6 now. Polynomials. Cube roots. Yeah, I think it's 5. Sorry. Okay, so 5. Now, what is this? Let's do something a little different. So we have 6 minus x, right? So 5. Let's change this actually, my bad. You could put 6 if you want, but I'm going to change it. 9 minus x. I'm going to tell you why later on. But now, okay, I'm going to tell you now anyway. I'm going to tell you now. The reason why is I gave an exact problem for honors pre-calculus. So if you want to find more problems, I just went over the basics, nothing complicated. So I gave 20 problems there. So go ahead and try that on if you want more practice problems. So 9 minus x, right? So try that out. We're almost at 20 minutes, so 10 minutes left. Probably gonna finish early today, so class will end early. Okay, So let's do this. My videos is usually about 30 minutes long, if you're wondering. Okay, so what is this? Well, with this equal to 0. So you get the first 4 questions right, good. Now it's a little bit tricky, right? You have to apply a little bit of algebra. Now we know domain, so we just have to know what the algebra is. So this is negative x is greater than or equal to negative 9. X is less than or equal to negative 9. You notice here, because you're dividing by negative, you gotta flip the sign. And you plug in numbers, it makes sense, right? So it cannot be bigger than 9. Let's say I plug in 10 here. 9 minus 10 is negative 1. That's gonna give me negative inside. So I can't, it has to be, x has to be less than or equal to 9. So set notation, interval notation. That's it. Okay. Okay. All right, another one. 6. So 1 over x plus 3. Okay. So try that out. So basically, what do you get? Another tricky one, huh? Maybe tricky question. I didn't see a sample like that. It's okay. Just try to think about it. And you want to write f of x to be more precise. Okay, so this is gonna be x plus 3 has to be greater than or equal to 0, right? Nope, cannot be. Remember, it cannot be 0 on the bottom, so this is just x is greater than 3. X plus 3 cannot, has to be greater than 0. So then you subtract 3, you get negative 3. X has to be greater than negative 3. How many of you got that right? Okay, so this would be set notation and interval notation. Now this time it's a bracket because it's open, it's not included. Alright, so interval notation, set notation. Alright, let's do another problem. How about this one? X squared of x squared. So pause the video, try it out. So you gotta think a little bit, right? Some of these questions are tricky, so you gotta think. All right, so the inside, if I follow the rule, I get this, right? But the question is this always true? So if I plug in any x value, can I get a number? Yes, I can. So the domain of this is all real numbers because I can plug in any number. I can plug in, let's say, whatever number you want, f of 1, f of 0, f of negative 1. It doesn't matter, I'm gonna get an output out of it. This is square root of 2, this is 1, this is square root of 2. So that's why the domain of this is all real numbers. Does that make sense? So let me write on this number 7. Okay. So let's do one more. Let's do the same thing. 1 over x squared plus 1. So what do you think the domain of this one is? Okay, getting the idea of this, you would know the domain of this is all real numbers, right? But the question is why, right? If you're wondering. Because in here, it has to be positive. In this case, it cannot equal 0, so it cannot be 0 or positive, but when is this going to be 0 or when is it going to be negative? So this is always true, so I can say the same thing, x squared plus 1 is greater than 0. So you have to think, okay, what's the domain of that? The domain is all real numbers because this is always positive. And wow, how do I know this is always positive? I mean, just think about the graph, x squared plus 1. So when is it positive? It doesn't matter, this is your x value, this is your y value. So it doesn't matter where your graph is, it's always positive. So that's why this is all real numbers. That's one way to think about it. Okay? So there you go. Hopefully this makes sense by graphing it. Alright. Alright, last one. This should be the last one. So f of x equal to 1 over cube root of x. Okay. So what's the domain of this one? Our domain of cube root is all real numbers, but since it's the bottom, can I plug in? Let's just plug in numbers, right? So we got f of 1, f of 0, f of negative 1. Let's try f of 1, I get 1, f of negative 1, I get negative 1, f of 0, I get 1 over 0, so it cannot be true. This is undefined, right? Undefined, undefined, okay? So, boom, that's an underline, meaning it's continuing, undefined, okay? So in this case, the domain of this is instead of all x, that x cannot equal 0. This is set notation. You want to write interval notation, it would be something like this. That's it. So the last, 5 questions, that was a little tricky, right? I meant to kind of have you think a little bit. You know, if you didn't get the first 4 and then you didn't get the last 5 or you missed some of the question, that's okay. So just think about it. Why, right? So I had a problem. I'm using a Stewart book. I don't need to. I'm using a Stewart book. I mentioned that in day 1. What book I'm using. I showed what the book looks like. I don't have the book with me, but it's a Stewart book, 5th edition. I have a problems page. I don't remember exactly the page, but number 1 to 6. Let me look it up. 41. So you can see 6 problems, right? Not a lot. So I don't really like to give a lot of problems. I like students to be able to understand the problem and why that's the answer. And another way to do it is redoing the problems, make sure you understand it, or teach somebody. I really like that, be able to teach somebody. If you can teach somebody how to do a problem, you really understand it.